There is a fighter plane sitting in museums around the world with wings that bend in a way no other aircraft does. Not swept, not delta, bent. Like someone grabbed the wings mid-build and folded them downward at a sharp angle. Engineers call it the inverted gull wing. Most people just stare at it and ask the same question: why? The answer is not what most people expect. It was not for speed. It was not for maneuverability. It was not even for aerodynamics, at least not originally. It was a chain reaction of problems, each one forcing a solution that created the next problem, until Chance Vaught's engineers arrived at one of the most iconic silhouettes in aviation history. This is the real story behind the bent wings of the F4U Corsair. To understand the wings, you have to start with the engine. In 1938, the U.S. Navy issued a design challenge to build the fastest, most powerful carrier-based fighter America had ever produced. Chance Vaught's answer was to take the biggest, most violent piston engine available at the time, the Pratt Whitney R-2800 double wasp. This engine was a monster. 18 cylinders are arranged in 2 rows, over 2,000 horsepower. Nothing on a carrier deck came close. But raw power alone does not win a war. You need to convert that power into thrust, and that means a propeller. The R-2800 demanded a propeller large enough to match its output. The solution was a 13-foot, 4-inch Hamilton Standard 3-blade prop, one of the largest ever fitted to a single-engine fighter. And right there, the first major problem appeared. On a carrier, you land on a short, moving deck. Your landing gear has to be strong enough to absorb brutal impact loads. But that enormous propeller sitting up front, it needed clearance from the deck. If the landing gear was too short, the propeller tips would hit the ground. If the landing gear was too long, the legs would need to be massive, too heavy, too complex, and too fragile for the shock of carrier landings. Vaught's engineers were trapped. Big engine, big propeller, short, usable landing gear. Pick any two, you cannot have all three. At least, not with a straight wing. Here is the insight that changed everything. If the wing is mounted straight and level, the landing gear must extend all the way down from that height to the ground, carrying the full burden of the propeller clearance requirement. But what if the wing itself dropped down before rising back out to the wingtip? What if the lowest point of the wing became the mounting point for the landing gear? That is the inverted gull wing. The wing drops sharply down from the fuselage, hits a low point at the bend, and then angles back upward toward the wingtip. The landing gear mounts at the very bottom of that bend are already close to the ground, which means the gear legs can be dramatically shorter. Shorter legs mean lighter weight, simpler mechanics, and far greater structural reliability under the punishment of carrier landings. The propeller clearance problem was solved. Not by changing the propeller, not by changing the engine, but by reshaping the wing itself to bring the gear attachment point down to where the ground already was. But something unexpected happened when the engineers ran the aerodynamics. By angling the wing down and then back up, they had inadvertently reduced the junction between the wing root and the fuselage from a perpendicular angle to a more favorable one. That junction, called the wing-body interference zone, is a major source of drag on conventional fighters. The gull wing shape naturally cleaned it up. The Corsair, designed around a mechanical constraint, ended up being faster because of it. The Navy tested the F4U through its standard trials. It passed. Fast, powerful, maneuverable, it checked every performance box. Then came carrier suitability testing, and the problems started stacking up. The gull wing that solved the landing gear problem introduced a new hazard on approach. As the Corsair slowed for landing, one wingtip, almost always to the left, would stall before the other. Without warning, that wing would drop sharply. On a carrier approach, with the deck rising and falling in front of you, a sudden wing drop is not just dangerous, it is often fatal. Pilots started dying. The aircraft earned the name the Ensign Eliminator. The second problem was visibility. The nose of the Corsair stretched far out in front of the cockpit, long enough that during the final approach, with the nose pitched up to bleed speed, pilots lost sight of the carrier entirely. The LSO, the landing signal officer, standing at the deck's edge, guiding every approach by hand signal, simply disappeared behind that massive engine cowling. You were landing blind on a moving ship in the open ocean. The Navy made a decision. Hand the Corsair to the Marine Corps for land-based operations. Let someone else sort out the carrier problem. The Marines accepted, put the aircraft over Guadalcanal, and the Corsair began destroying Japanese aircraft at a rate that made everyone reconsider how bad the plane actually was. It was not a bad plane. It was a plane that needed the right fix. The fix came partly from America, partly from Britain, and together, those two contributions cracked the carrier problem for good. The wing drop was solved with a stall strip. A small, almost invisible metal tab was added to the leading edge of the right wing near the root. Its job was simple: make the right wing stall at the same moment as the left wing. No more asymmetric drop, no more sudden roll on approach. A piece of metal smaller than a pencil made the Corsair manageable. The visibility problem took more creativity. British Fleet Air Arm pilots, operating Corsairs on Royal Navy carriers, had less room to work with and less tolerance for written-off aircraft. They developed a curved approach instead of flying straight down the centerline toward the carrier and losing the deck behind the nose. They flew a continuous curving turn all the way to touchdown. The carrier stayed visible out the side of the cockpit throughout the entire approach. They only rolled wings level in the final 2 seconds before the wheels hit the deck. The British also made physical changes to their Corsairs. They clipped the wingtips, removing several inches from each side. This was initially done to fit the aircraft into lower clearance British carrier hangars, but the clipped tips had a secondary effect. They improved the stall characteristics on approach, making the aircraft safer to land. They also raised the pilot seat and modified the canopy for better forward visibility. When the U.S. Navy observed what the British had worked out, the response was straightforward: adopt the curved approach, implement the stall strip, and return the Corsair to carrier operations. By 1944, the Ensign Eliminator was cleared for fleet use. Once the carrier problem was solved, the Corsair proved what it had always been: a superior fighting machine. Its kill ratio against Japanese aircraft reached 11-to-1. It was faster than anything Japan could put in the air in significant numbers. It absorbed punishment that would have destroyed lighter-built fighters. Its range extended strike operations further than anything else on the carrier deck. It fought on through Korea. It flew for El Salvador and Honduras. And in 1969, more than 20 years after World War II ended, Corsairs and P-51 Mustangs were still shooting at each other in a conflict called the Soccer War. The airframe that nearly never made it onto a carrier outlived nearly every contemporary by decades. Every time you look at those bent, curved wings, you are looking at a series of forced compromises that turned into a legend. The engine demanded the propeller demanded the clearance demanded the gull wing. The gull wing created the landing problem. The landing problem forced the innovations that made the aircraft genuinely great. The curve was never the plan. It was the solution. And that solution is why the F4U Corsair is still one of the most recognizable aircraft ever built. If you want to see the rest of what makes this aircraft unique, the first kill, the German capture, the battles with former allies, That full breakdown is in the next video. Subscribe so you do not miss it, and drop in the comments which aircraft you want covered next.